Hello everyone. Today we'll be looking at multiplying and dividing complex numbers. Okay, so we're going to start off with multiplying. And before we do that, I want you to remember that complex numbers are not real numbers. Okay, so you won't be able to just solve them the same way you would real numbers. Alright, so let's say, for example, for complex numbers, let's say if you want to multiply square root of -4 times the square root of -9. Okay. So if you had real numbers, let's say square root of 4 times square root of 9, just +4 and +9, you can put them together under the same square root and make them square root of 4 times 9 or square root of 36. You can't do that here. Okay, now you could do that a little bit differently, because remember, this is just I times square root of 4 times I times square root of -9. So let me make this a little bit clearer. There we go. Okay. And remember, multiplication is commutative, so we can switch those all around. So you have square root of 4 times square root of 9 times I times I. Okay, so if you remember from the last video that introduced complex numbers, I is equal to the square root of -1. So if you square both sides, that gives you I squared equals the square, and the square root would cancel out. So I squared equals -1. So if you remember from the last video, kind of treat these, so if you had x times x, you'll get x squared. Same thing here. I times I is I squared. Okay, so square root of 4 plus or minus 2, but we're just going to use 2 times square root of 9. It's going to be 3. And I times I is I squared. So really, this will give you 6 I squared. Now, if you were dealing with just variables, you'd be done here. So if you had x here, it would just be 6x squared, and that would be your answer. But I is an actual number, and so is I squared. Since I squared is equal to -1, this now becomes 6 times -1, or -6. Okay, so you want to remember these two when you're multiplying complex numbers. Okay, we're going to get into if the values are bigger or not, but for right now, just looking at the square. All right, so let's move on to our first example. Okay, so let's say, for example, we wanted to multiply square root of -2 times square root of -20. All right, so we're going to go ahead and solve this one. Okay. Now the first thing you want to do is realize that square root of -2 and square root of -20, you can make that I times square root of 2 times I times square root of 20. Okay, so just like we did before, we're going to go ahead and shuffle those around. You don't have to, but sometimes it makes it easier to visualize. Let me give that a little more room. That I times, there we go. Okay, so you have square root of 2 times square root of 20 times I times I. And once again, I squared equals -1. So if we go ahead and combine those two, we have square root of 2 times 20 times I, which is I squared. Okay, so square root of 2 times 20 is square root of 40, and I squared, you see, is equal to -1. So square root of 40 times -1. Okay, now that square root of 40 is not a perfect square, but it has a perfect square as a factor. Okay, so if you look here, you have your square root of 40. That equals square root of 4 times 10. Okay, so we can go ahead and separate those two. So we have square root of 4 times square root of 10. Square root of 4 is 2, so we have 2 square root of 10. Okay, so that becomes 2 square root of 10 times -1, or you can just make it -2 square root of 10. Okay, so if you multiply square root of -2 times square root of -20, you end up with -2 square root of 10. All right, so let's go ahead to our next example. Okay, so what if we wanted to multiply, let's say for problem A, you have 6 times 2 plus 9i. And let's say for problem B, you have -5i times 4 minus 8i. Okay, so for problem A, 6 times 2 plus 9i, we use the same distributive property that we've been using. Okay, so 6 times 2 is 12, plus 6 times 9 is 54, so that gives us 54i. Okay, so that would be your answer there. But for problem B, you go a little bit further. So -5i, 4 minus 8i. We still distribute. So -5 times 4 is -20, so you have -20i. Now -5i times -8i will actually give you positive 40i squared, because I times I is I squared. But once again, you can't forget that I squared equals -1. That gives you -20i plus 40 times -1. Okay, so you end up with -20i minus 40, which actually equals -40 minus 20i as your answer, because most of the time they will want it in a plus bi form. Okay, so your a would be -40, your b would be -20. Alright, so let's go to our next example. What if you wanted to multiply -4 plus 2i and 2 plus I, and you wanted to write in a plus bi form? Okay, so what I want you to do is you can multiply this using the FOIL method. I want you to try this one. Press pause and try this on your own. Alright, so assuming you've pressed pause and solve this one on your own, we have -4 plus 2i and 2 plus I. We go ahead and use the FOIL method. You have your outer, which is -4 times I, so -4i. Oh, yep, I'm sorry, I'm going out of order. This would have been your first. I don't know why I went right to the outer. Okay, so it should have been first. So that should have been -8i. -4 times 2 is -8. Then your outer. -4 times I. Still put the I there for some odd reason. So you have -4i. Then your inner, 2i times 2. So plus 4i. And your last is 2i times I. Is plus 2i squared. Okay, so -4, 2, -8. Outer, inner, yep. Okay, to make sure I didn't make any more mistakes. Okay, so you have -8 minus 4i plus 4i plus 2i squared. Okay, now these two you can combine. Okay, so minus 4i plus 4i actually cancels each other out. Okay, so you have -8 plus 2i squared. Okay, so remember I squared equals -1. So we end up with -8 plus 2 times -1. Okay, which ends up being -8 minus 2, which is -10. Okay, that's your answer, but it has to be in A plus BI form. So that -10 will become -10 plus 0i. Okay, remember, that's your A plus BI form. Okay, that's very important to remember, especially if the question asks you specifically to put it in A plus BI form. Alright. So let's go ahead to our next example. Okay, so what if we wanted to multiply say for problem A, 2 plus 3i, 3 minus 2i, and let's say for problem B, you have square root of -80 times square root of -80. Okay, so for problem A, you have 2 plus 3i, and 3 minus 2i. We're going to go ahead and use the FOIL method again. So your first is 2 times 3, which is 6. Your outer is 2 times -2, which is -4i, 2 times -2i. Your inner is 3i times 3, which is positive 9i. And your last is 3 times -2, so you have -6 and the I squared. Okay, so there's two things we can do to this one. Remember that I squared equals -1, and we can combine those two terms. Okay, so that equals 6, -4i plus 9i, positive 5i, minus 6 and I squared makes that times negative 1. So if we simplify those terms, we have 6 plus 5i. Negative 6 times negative 1 is positive 6. Okay, so we can actually go ahead and combine those two. So 6 plus 6 is 12. So we have 12 plus 5i. Okay, remember that's our a plus bi form. Alright, so let's go ahead and start on question B. Okay, so you have square root of negative 80 times square root of negative 80. Okay, remember, square root of negative 80, you can make that I times square root of 80 times I times square root of 80. Okay, so you can go ahead and switch those around if you want. So you have square root of 80 times square root of 80 times I times I. So you can go ahead and combine those two and put them all under one root symbol. So you have square root of 80 times 80. Okay, and once again, remember that I squared is equal times I squared. I squared equals negative 1. Okay, so move that up. So if you remember, 80 times 80, you can just make that square root of 80 squared. And I squared times negative 1. Okay. So once you do that, remember, this is an index of 2. The index and the exponent cancel each other out. So those two would cancel out, and you're just left with 80 times negative 1, or just negative 80. And if they wanted that in a plus bi form, that would be negative 80 plus 0i. Okay. So as you can see, with multiplication, it's the same as if I were a variable. When you have just the one I, you kind of treat it like it were an x. But it's when you run across the I squared that you have to remember to replace it with negative 1. Okay, the regular I, that just get moved around like a variable. Like I said, same way you would x. But you have to remember that part. Okay, move that back up a little bit. Alright, so if you're still writing, feel free to press pause. But right now, we're going to move on to dividing complex numbers. Oops. Oops. Here we go. Okay, so dividing complex numbers. Okay, so before we get started, I want you to remember when we were messing around with our square roots and all of that stuff, you have 2 plus square root of 3 and 2 minus square root of 3. You remember, that's what they call conjugates of each other. Okay, really, two terms are the same, they just differ by a sign. Okay, those are conjugates of each other. Okay, now with that in mind, in general, you have a plus bi and a minus bi. those are what you call complex conjugates of each other. Okay, same thing. You have your A and BI, they just differ by a sign. Alright, so for example, if you have 7 plus 4i and 7 minus 4i are complex conjugates. Of each other. Or, let's say if you have 5 plus I and 5 minus I are complex conjugates. Okay, same terms, just changing the sign. Okay, but what if you have something like negative 6i? What would be that complex conjugate? Okay, now the way you would approach this is to remember that negative 6i, you can write that as 0 minus 6i. Straighten that up, there we go. Okay, so you can write that as 0 minus 6i. So that means 0 minus 6i and 0 plus 6i are complex conjugates. Okay, remember 0 minus 6i is just negative 6i. And 0 plus 6i is just 6i. So negative 6i and 6i are complex conjugates. Okay, it's all about changing the sign that's in front of the complex number. See, this one's just a complex number. So by it being just a complex number, you just change the sign in front of that value. Okay, now just a little extra tidbit of knowledge. If you multiplying a complex number, which we'll say a plus bi, and its conjugate, which is a minus bi, will give the real number a squared plus b squared. Okay, so if you multiply these two conjugates together, you'll end up with a real number as an answer. Okay, so let's say, for example, excuse me. Okay, so for example, we wanted to multiply 3 plus 5i. I don't really need the colons there, by its complex conjugate. Okay, so if we have 3 plus 5i, we want to multiply it by its complex conjugate. That means the complex conjugate of 3 plus 5i is 3 minus 5i. Okay, so if we have 3 plus 5i times 3 minus 5i, and again we do the FOIL method, we're going to end up with, remember if we do our first, that will give us 3 times 3, which is 9, I don't know why I said 5. Then we do our outer, 3 times negative 5 is negative 15i. Then if we do our inner, 5 times 3, we have positive 15i. And if we do our last, we have negative 25. Then I times I gives you I squared. Okay, so these two middle terms will cancel each other out. So you're left with 9 minus 25. And remember, I squared equals negative 1. So negative 25i squared is minus 25 times negative 1. Okay, so you end up with 9 minus negative is plus, so plus 25. So you have 34. And it didn't say put it into a plus bi form, so we can leave it as 34. Okay, now using, oh, where'd it go? Here we go. This formula from the previous page, right at the bottom. You multiply two conjugates, you have a squared plus b squared. We know that 3 plus 5i, we know that a is equal to 3 and b is equal to 5. So if we wanted to multiply 3 plus 5i times 3 minus 5i, that will be just going from the formula. Remember, a plus bi times a minus bi, be a squared plus b squared. Okay, so if we know a is equal to 3 and b is equal to 5, that should give us a squared, which is 3 squared. We'll move that up a little. So we have 3 squared plus our b squared plus 5 squared, which gives us 9 plus 25, which gives us 34. Okay, so even if you choose not to use this formula, you're just a FOIL method away from the right answer. Okay, so pretty much the choice is yours as to which one you want to use. If you're okay with memorizing this, you're good. But if not, the FOIL method will give you the same thing. All right. Okay, so let's go to our next example, where we're going to look at dividing complex numbers. Now, there's one key thing you want to remember when dividing complex numbers. So to divide complex numbers, multiply the numerator and denominator by the complex conjugate of the denominator. Okay, just the complex conjugate of the denominator. Alright, so let's say, for example, you asked to divide 3 over 6 plus I. Okay, so I'm just going to write that down. 3 over 6 plus I. Now remember, we have to multiply the numerator and denominator by the complex conjugate of the denominator. So the denominator, we know that the complex conjugate is 6 minus I. Okay, so since we know the complex conjugate of the denominator is 6 minus I, that means we have 3 over 6 plus I, and we can go ahead and put that in parentheses, times 6 minus I over 6 minus I. Okay, so right there we just multiplied the numerator and denominator by the complex conjugate of the denominator. Okay, now if you want to just put those under one numerator and denominator, you can just make that 3 times 6 minus I over 6 plus I times 6 minus I. Okay, now for your numerator, you're just going to go ahead and distribute. Your denominator, you're going to use the FOIL method. Alright, so if we go ahead and distribute, 3 times 6 is 18. 3 times negative I is negative 3I. All over, we're going to go ahead and use the FOIL method, or you can use the a squared plus b squared. I'll use the FOIL method. So you have your first, which is 36. Your outer, negative 6i. Your inner is positive 6i. And your last is negative I squared. Move that up a little bit. There we go. Okay, so these two middle terms are going to cancel each other out. So you have 18 minus 3i all over 36 minus negative 1. Because you remember, I squared equals negative 1. Okay, so that gives us 18 minus 3i over 36 plus 1, which is 37. Okay, now if you wanted to, if they asked for it in a plus bi form, you can just separate this fraction. We'll put the denominator under each numerator. So you have 18 over 37 minus 3 over 37i. And this is your a plus bi form. Alright, and again, if you wanted to, 6 plus I times 6 minus I. If you want to use the formula, remember here, A is equal to 6, and B is equal to 1. So your A squared plus B squared would just become 6 squared plus 1 squared, or 36 plus 1, which is 37. So either way, you would have still got the denominator of 37. Okay, so yeah, like I said, your FOIL method or the formula, you'll get the same thing. Completely up to you. Alright, so let's go ahead to our next example. Okay, so let's say, for example, if we wanted to divide 1 plus 2i over 3 minus 4i. Alright, so what I want you to do is press pause and try to solve this one yourself using the same steps from the previous problem. Alright, so assuming you've pressed pause and solved this one, let's just verify it. So writing down our original problem, we know here that the complex conjugate is 3 plus 4i. Okay, so that means we have 1 plus 2i over 3 minus 4i, and we can go ahead and put parentheses around those, times 3 plus 4i over 3 plus 4i. So if you want to, you can put those over the same fraction. So 1 plus 2i, 3 plus 4i over 3 minus 4i, 3 plus 4i. You don't have to. If you wanted to, you could have solved it right here, but I just chose to do it that way. So if we do the FOIL method here, our first is 1 times 3, which is 3. Now our outer is 1 times 4i, which is 4i. Our inner, 2i times 3, which is 6i. And our last is 2 times 4, which is 8. So plus 8i squared. Okay, we do the same thing in our denominator. 3 times 3 is 9. Our outer is plus 12i. Our inner is minus 12i. And our last is minus 16i squared. Okay, now for both of these, we know that I squared equals -1. In our denominator, those two cancel out. In our numerator, we can just combine those two I values, or I terms. Sorry about the shadow, the sun's moving. Okay, so you have 3 plus 4i plus 6i is positive 10i, plus 8 times I squared, so 8 times -1, all over 9 minus 16 times -1. Okay, so if we go ahead and simplify those, you have 3 plus 10i minus 8, 8 times -1, over 9 plus 16. Alright, so if we go ahead and combine those two, 3 minus 8 is -5. So you have -5 plus 10i all over 25. Okay, which is equal to, if we go ahead and separate it, -5 over 25 plus 10 over 25i. Okay, now if we simplify those fractions, you have -5 goes into 5 one time, 5 goes into 25 5 times, plus 5 goes into 10 twice, 5 goes into 25 5 times, and I. Okay, so you still have to simplify your numerical fractions if you have them. Alright, so let's go to our next example. Alright, so let's say, for example, we want to divide, say 4 plus square root of -16 over 2 plus square root of -4. Okay, now with that -16, we can kind of simplify that a little bit. So 4 plus I times square root of 16 over 2 plus I square root of 4. Okay, so that's equal to 4 plus square root of 16 is 4. So 4 plus 4I over 2 plus square root of 4 is 2. So that'll be 2I. Okay, now before we multiply by the complex conjugate of the denominator, notice we can factor a 2 out of both of those. So we have 2 times 2 plus 2I over, and you have 2 plus 2I down here, you can make that 1 times 2 plus 2I if you like. These two cancel each other out. So you end up with 2 over 1, or just 2. Now if they wanted it in A plus BI form, it would be 2 plus 0I. Okay, so even if you did go through the steps of multiplying by the complex conjugate of the denominator, you'd still end up with the same answer. This is just an example of sometimes you can get lucky and have one just simplify right in front of you where you don't have to go through all that extra work. Alright, so let's do another example. Okay, so what if we want to divide 7 over 2I? Okay, so 7 over 2I, we know that the complex conjugate of the denominator is negative 2I. Okay, so that means 7 over 2I, you're going to multiply that by negative 2I over negative 2I. And again, if you want to put them next to each other, you can. Over 2I times negative 2I. Okay, so 7 times negative 2 is negative 14I. All over 2 times negative 2 is negative 4, and I times I is I squared. And remember, your I squared equals negative 1. Bring that up some. So you end up with 14I over 4 times negative 1. Because negative divided by negative is positive. But that negative 1 at the bottom makes that 14I, move that, over negative 4, but we can bring the negative in front, over 4. Okay, and that's simplified because 2 goes into 4 twice, and 2 goes into 2 goes into 14 7 times. So we end up with, let's clean that up a little, negative 7 over 2I. But if we wanted to write that in A plus BI form, of course that's 0 minus 7 over 2I. Alright, so let's do one more quick example. What if we wanted to divide negative 1 plus 9I over negative I? Okay, so what I want you to do is go ahead and press pause, and I want you to try this one on your own. Alright. Alright, so assuming you've pressed pause and worked this one out, you have negative 1 plus 9i over negative I, and you have your denominator there. And your complex conjugate of your denominator is I. Let's clean that up a little bit more. There we go. Okay, because remember, you're just changing the sign in front of the complex value. So since it's just a complex value, it's just I. Okay, so we have negative 1 plus 9i over negative I, and shorten that up a little bit, times I over I, or you can just make that negative 1 plus 9i times I over negative I times I. Okay, so this, we go ahead and distribute. We have negative I plus 9i squared over I times I is I squared, so we have negative I squared. And remember, I squared equals negative 1. Okay, so that means we have negative I plus 9 times negative 1 all over negative 1. Okay, remember that negative's on the outside. Okay, so that equals negative I minus 9 over positive 1, which comes out to just be negative I minus 9. Now, if they want that in A plus BI form, that would be negative 9 minus I in your A plus BI form. Alright, so hopefully the multiplication and division of complex numbers made sense. And I will see you on the next video.